A 0.5 kg mass is in contact against the inner wall of a cylindrical drum of radius 4 meter rotating about its vertical axis. The minimum rotational speed of the drum to enable the mass to remain stuck to the wall without falling is 5 radian per second. The coefficient of friction between the drum's inner wall surface and the mass is. So that means here a drum which is rotating. So here a drum which is rotating about its vertical axis. That means the drum is rotating about its vertical axis. Now one mass, due to the rotation, it stucks to the inner wall of a cylindrical drum. Now, since we talk about the rotation, so we know that centripetal force Fc is the force which is needed for an object of or any object to move in a circular orbit. So to move in a circular orbit of mass m, we can write that Fc equals to m v square by r, where r is the radius of the circular path. So here you can see, due to the rotation of the cylindrical drum about the vertical axis is responsible for the object to remain stuck to the wall. So therefore we can say that mg, where m is the mass of the object, is always g always towards the downwards. Now due to the rotation, the object will get an reaction force, which is due to the Fc, centripetal force, because the centripetal force due to the circular motion is always towards the center. There is also, if I take the radius is capital R, then we can write Fc will be the nothing but the normal, right? So therefore we can write the normal n equals to m v square by r, or also you can write m omega square r, because v equals to omega r, and here the 5 radian per second angular velocity is given, that is 5 radian per second. So therefore we can write that n equals to m omega square r. Now if I want to consider the friction case with a similar thing that we know from our book, that is W weight, normal reaction n. If a force F applied along this direction, due to this the object start moving along the direction of the force, then the frictional force will be in opposite direction. So according to the friction law, we can write that friction force F proportional to normal reaction n, or we can write F equals to mu n, where mu is the coefficient of friction. So therefore, if the object is not moving, then the basic tendency of the object will be moving towards the direction of the gravity, which is towards the downward direction. Due to the motion, the object could not fall, it is stuck. That means the frictional force between the drum, inner surface of the drum, and the mass will be in opposite direction, that means in upward direction, which we can write as a small f. Okay, so that means the frictional force F, the suffix S, frictional force. Okay, now my question is that what will be the minimum frictional force that is required for the mass M to stuck on the inner surface of the drum, which will be, we can say, Fs if less than equals to friction F. Now this friction F is nothing but the F equals to mu m. If I want to draw the free body diagram, then you can draw, this is the diagram for a FBD, means free body diagram. So this will be the normal reaction N, and here the direction of the friction, say F. Okay, so here friction F equals to mu N. So as we can see, according to this frictional law, we can write F equals to mu N. Now if I want to write all those values here, If I write Fs, say for Fs, then we can write Fs, the basic tendency Fs will be equals to mg, right? Because it balances mg if it is stuck. If it is not fall, then obviously it should be equal or less than the friction of f, small f, which is mu into m omega square r. Again, I am repeating this concept. If the object is stuck on the wall, then without the rotation of the drum, the object must fall towards the downwards, that is towards the ground. Then the friction, if I take as a Fs, then the when it is rotating, when the drum is rotating, then obviously Fs should be equals to mg because it remains stuck. That is given to the question. Now, what is the minimum rotational motion? So this is the minimum. So you can say that it is if mg, mass of or weight of the object, will be less than equals to the f, that is m omega square r, then it will be minimum. So from here we can calculate, cancel out. We can write that is mu equals to g by omega square r. It is preferable to not write equal rather than greater than equals to g by omega square r. Now we can write the mu minimum. Now what is the minimum value? That will be g by omega square r. Now the value of g is given as a 10 and omega is given as a 5, which will be 5 square, into the radius it is given as a 4. We don't need to change any unit here. So 10 by 25 into 4, that is 10 by 100, equals to 0.1. So that means the value of the coefficient of friction, or rather than we can say the minimum value of the coefficient of friction will be 0.1 between the inner drum's inner wall surface and the mass. Thank you.